Yes, you are live. You are looking at Discord birthday bash screen.
Sweet. It's working. Can you see me? Can you see me on the screen too? Like waving?
Upper right
Yeah.
corner. Yes.
Yeah. Okay.
Yep.
Perfect. Hey, look at this technology. It's freaking working.
Of course, you would ask a blind guy if you could see you in the upper right corner.
Sorry.
But, no, I got you. I just had to zoom out and like, what corner is he in?
Happy birthday.
Thank you. Thank you. Appreciate it. While whopping 70 years old.
70? Yeah, you look great.
Looking good.
I feel like, yeah, at least at this rate, you'll be able to easily make it 150, 160.
Exactly. I'm gonna break all the records. Just getting everything set up here.
Yep. All right, so I can guesstimate the majority of the logos on the birthday bash. Clearly, we have a TrustedSec. I'm assuming a derby or some kind of that's not a derby though, is it?
So there's a derby hat on there. Yep, a derby hat. So
Okay.
I love tacos, Mexican food. I love video games,
That's all right,
basketball.
Is that an Evil Corp?
It is an Evil Corp sign. Yep, yep,
Okay, okay.
yep. Computers,
Okay,
obviously.
cabinet.
Yep,
Yep.
yep. Thanos. So a big superhero fan.
Yep. What are these flags or sites or?
That is the Cavaliers logo for basketball.
Ah.
Yeah, yeah. Got the Doctor Who TARDIS. What can you pick? Can you make that icon top right, second down?
Top right, second down. Oh, okay. Yep, yep.
That is it's actually a tattoo that I have on my arm. It's the Destiny logo for Titan, like a strong class in video
Oh,
gaming.
yeah. Okay, okay. Basketball, of
Cool.
course, and then
Yep.
computers. There. Okay, okay. Now we got them all.
I appreciate that it's like an old style PC on top of one of those boxes. Like I'm picturing the yellow plastic.
Oh, geez.
Got to do the old and the new, you know.
Yeah.
So the yellow plastic on top of the steel that was actually used was the case.
Yep.
Now we just have steel cases, which for some reason cost more.
I was watching a video of or episode of Pawn Stars, and Rick went to, I think it was like Chicago or something like that, to actually purchase the Apple One, and it was like legit from the it was like the very first iteration of the Apple One in the garage with Steve Jobs' garage, with Woz, and it was going for over $1 million. I think it was like $1.5 million or something like that.
Oof.
Yeah,
Did
crazy.
he get it?
No, he did not get it. He tried, he's like, nah, this isn't my skill set, so I'm gonna not do that. So
That's cool as hell though.
gonna have a lot of
Yeah.
keyboard clickety clanky. Cost. Sorry about that.
I actually got the RTX voice software on this machine,
Yeah.
and when I'm on basically Razer's equivalent to blue switches. So I used to really piss off my students when I was teaching, but now they don't hear it at all. It completely eliminates the clicky clacks.
I've heard a
Yeah,
lot of
RTX
people.
voice is the shit.
It's
It is amazing.
unbelievable.
I've heard a lot of people say it's absolutely incredible.
And I was in a Linux environment for like 2 years, and when they dropped it and the beta worked so well, I was like, well, I pretty much have to go back to a Windows environment to teach now.
Yeah. I'm curious. So I just put on the beta noise cancellation from Discord. Can you still hear me okay?
You sound different.
I'm curious about it. You already do sound a little like distorted.
So let's see. Can you hear this?
Only at the
Come
tail
on.
end of you talking. Only at the tail end of you talking.
Okay. I was typing
pretty
super
cool.
hard.
This SMR.
Yeah.
I was typing really hard.
Dave SMR.
Hello. Now we gonna jump.
So do I sound worse or better with the with the stuff on?
Oh, it sounds like you're in a box, but it's fine.
It sounds fine, but it's inserting I love VI references.
Hey, who's that? How do I kick him out of the room here? So. Okay, so let me try one thing here really quick. Permissions. Okay. And then I need to do rhythm. And then how do I set We'll get started in just a second. I'm trying to jam with some music here, and it's a last minute thing. So we'll see if this works. Okay, that makes sense. Okay, let me see if this works, okay? 1 second. So there may be some not safe for work music here, just an FYI. If anybody gets offended, I apologize. Not really gonna apologize, but
Don't worry, I'm driving past the preschool. I'll just crank it.
Yeah, that could have a couple different meanings there.
Why isn't that working? Oh, here, hang on 1 second. All right, let me try that 1 second. All right, 1 second, 1 second. Just getting the volume down 1 second. All right, how's that? Can everybody hear okay?
Your mic is super low.
All right, 1 second. One second, just getting this worked out. Why not do it live? How's that? Is that better? Can everybody hear me okay? All right, can everybody hear me okay?
Yeah, I can hear you, no problem, man.
Did it sound good with the music on or no?
Yeah, sounds great.
Well, I mean,
Just keep waiting.
with the music on, can you still hear me okay? What's that?
I was thinking this was like podcast intro.
Do I sound good with the music on? Yes or no? All right, I guess that's
The
no.
music is still low.
It's low.
Yeah.
Yeah, but can you hear the music and me talking at the same time?
No.
Okay, we'll
so
just
loud.
we'll just discard the music. That was a last attempt there, but we'll figure it out. No worries. All right. Well, hey, we'll kick this off. So I appreciate everybody hopping on to my birthday bash. So thank you everybody for hopping on. I know there's some folks on Discord. If you're not on Discord, it's just I'm sharing on Twitch. So it's twitch.tv/hackingdave. So if you just go to Twitch.
If people aren't hearing you, I think you better to remove the rhythm mode.
To remove what?
Rhythm. This is the one that is playing loud music.
Well, I turned off the music's gone. The music's off. So can everybody hear me okay?
Yeah.
Okay, good.
No, yeah, it's clear.
Okay. So appreciate everybody hitting on today. 1 second, let me get rid of that one. That's not what I want to show. Or that. 1 second. There we go. All right. So if you're not seeing my screen, it's on twitch.tv/hackingdave. So today, I thought it'd be cool just to hang out, talk, hack some code together, and talk about command and control. That seems to be like a very fun topic for a lot of folks, and there's a lot of reasons why building your own customized command and control is a big deal, and things that you can do to get around certain things around evasion. So this is going to be everything from a beginner to intermediary. And my goal is to hopefully do some more of these as we go along. So definitely do more series like this, Hangouts and Discord, all that other stuff. If you're on Twitch, you can join us on the general voice channel. It's just discord.gg/TrustedSec, and we're having a good time here. But I just want to thank everybody for hopping on, and we'll kind of go through and talk through some of the different areas here around command and control. And I'm not going to spend a lot of time on slides. Most of it's going to be actually going in and doing the coding and everything else. But I wanted to give a little bit of a precursor to kind of everything that's happening right now and talk about command and control and all the fun stuff around that. So why build a command and control when there's plenty of others out there? And there's no question. There's a lot of great command and control resources already out there today. And with anything out there, if you look at PowerShell Empire or any of the other ones that are out there, they come out of the box, and you have to take what others have written, and you have to customize it to yourself to make it your own. With command and control frameworks, it's great because you can essentially start to build your own infrastructure, your own way of doing command and control, and you can manipulate already existing code to do what's necessary. The drawbacks of leveraging public C2 infrastructure is that when a new C2 version comes out of Empire or other command and control infrastructure, the EDR products, the antivirus products are all on it. They're writing signatures right away. And so the time to live when something actually comes out versus when you can actually go and to use it without having to do some heavy obfuscation or changing of that code is a very small window. A good example of that is there's a tool that I wrote called Magic Unicorn, which is an obfuscation and exploitation framework for PowerShell injection for shellcode into memory through PowerShell exploitation. And with Magic Unicorn, I'll write a new version of Magic Unicorn, and then literally 2 or 3 or 4 days later, there's an update to an antivirus signature that goes into Texit. Now, getting around that's absolutely trivial. You just do some minor modifications to the code itself, figure out where it's actually triggering it, and there's the last Discord meeting that we had here about a month and a half ago. I showed how to get around all of these and where to find those locations and how you can build those out, and that's available on our TrustedSec website. You can find them there. But really, when you look at what you're trying to accomplish, can we build our own C2 infrastructure from scratch, and can we have a longer time to life to live on a specific endpoint itself? So that's what we're going to be really going through today is basically looking at our command and control infrastructure, building a command and control infrastructure, building a basic one from a Python prototype. And then we'll get a little bit more advanced as we go along. We'll talk a little bit about Trevor C2 and kind of the C2 behind that. And then we're going to get into actually building our own Python PE files and do Python all the things, which is kind of the objectives and goals today. Now give me 1 second here. I'm going to mute some folks. Actually, I'm not going to server mute you. I'll just mute you regularly because I hear some background noise. So give me 1 second. And you can obviously unmute yourself if you want. All right, we are, I think, all muted. Yes, good, perfect. Okay, so let's go through a really quick basics of what command and control is, and just this is, I'm sure a lot of folks already know this. Some may not. So I just want to give a brief introduction around command and control. So this is from US CERT. This came out a number of years ago around a Russian adversary called Grizzly Step. And this was taken, and this is kind of hard to see. I'm going to actually shrink this a little bit. The quality of the image isn't that great. So I will go that direction. Hopefully you can see it a little bit better. And so what happened here, this is during the 2016 election piece where the DNC got hacked. Most specifically, I think it was John Podesta's email that got compromised. And this was a nice graphic because it kind of represented the different APT groups that were involved, or the advanced persistent threat groups that were involved in targeting that specific infrastructure. And why a command and control infrastructure is really important, and why we go through simulations around these areas, is that we have a few different phases of an attack. We have the initial access phase, which is hey, we built a phishing exercise and we're going after a target, and our target, we have to get around their firewall. We have to get, if we're phishing, we have to get around their SMTP gateway protection mechanisms, and we have to get around their endpoint controls. And so we really have 3 or 4 or 5 or 6 or 7 different preventative or detective controls that we have to look at as we're going through and trying to target a specific infrastructure. And so why that's important to understand is that our attacks have to take into account all those different phases to where we get to if you look at the MITRE ATT&CK framework, the very initial stage of the MITRE ATT&CK framework, which is the initial access. So if we go through all of those ways of getting around preventative mechanisms, like for example, let's just say we have an Excel document that has macros in it and it's heavily obfuscated and encrypted, and it gets around the EDR products and endpoint protection products, and we go ahead and we execute that and we detonate on the system. What happens after the fact? How do we get code execution onto the system in the first place to allow us to establish a communication between the victim machine and the attacker's machine? Now, when it starts to get damaging to an organization is when you compromise the initial entry point, the initial access piece, and then from there you're able to establish a communication, to the attacker's machine, and then the attacker can then look for other things like privilege escalation, moving to other systems, or what we call lateral movement, to go to different systems on the network to get access to the data that they need. So all of these things are part of the attack cycle, and a command and control infrastructure is a very tiny part of it, but one of the most important parts, because that's ultimately what's going to be our main conduit into a victim environment that we're targeting. And so if you look at this specific graph here around the adversary space, you have your operational infrastructure, which is going to be potentially where you launch your attacks from, where you go after a specific system, where you're looking for specific areas to target an individual. And I'm getting a little bit of feedback here. I'm going to mute you. There you go. 1 second here. There we go. Muted. Got it. So from our operational infrastructure, we're going to launch our specific attacks. And there's a lot of things that you can do to mask your C2 infrastructure, to trick incident responders and things like that. Detections, a concept we call domain fronting, where you leverage a third-party, legitimate third-party service to forward your traffic to the back-end infrastructure that has your command and control infrastructure. There's ways of making it look more believable as you go through, and all of those things are steps that you need to plan out. We're not going to go into a lot of detail around setting up your command and control infrastructure. We're going to focus on building our own command and control infrastructure, but the operational infrastructure and what you use for that callback and how you set that up becomes important. Things like domain reputation, if you're not doing domain fronting. Domain reputation is big because a lot of companies will block newly registered websites or things that have low reputation. So having domains that have been existent for a while, have built up reputation and credibility, those types of things can really help you, especially when you're looking at a command and control infrastructure of legitimate information that when defenders go through, they may miss based on reputation alone. So our whole goal here, is to simulate an adversary and actually go through a test where we can effectively look at an organization's threat models. We can build those threat models off of the specific adversaries that are in play for an organization, and build our operational infrastructure, our command and control infrastructure, and attempt to identify where they have gaps in their weaknesses for monitoring detection. So all those things become really important as we go through and start to build out our command and control infrastructure, and as we look at the best ways to get that initial access. So our whole goal, and again, just to summarize what a command and control is just a simple way of gaining execution onto a system, and that code that's running communicates back to us. That's command and control, a way to operate that victim's host machine that we now have access or control over. And again, we might be in there with very limited access or limited rights, and we have to then do post-exploitation scenarios to do privilege escalation, process injection, lateral movement, exfiltration of data, all these different things. But again, our goal is to get around all of those preventative mechanisms and detective mechanisms that they have in place to go and execute. And so going back to this initial first slide here, when we're going to build our C2 infrastructure, I'm going to show you some examples of detection and how we can ultimately get around those detections and do something that's legitimate in nature. Now, again, this isn't going to be 100% for every organization. You have to do your homework and you have to research the targets that you're going after. But in this case specifically, we're going to target just a Windows 10 machine and going after that specific one there, okay? If anybody has questions, feel free to unmute and ask or talk or whatever you want to do. No problem. Don't be obnoxious though, I'll banhammer you. Either way. All right. So what we're gonna do first is we're gonna go into our Windows 10 machine, and I want to show you a blog post that I wrote back in 2011. And this blog post, what I thought was really interesting, and I've talked about this a few different times. Oops. And this blog post that I wrote back in 2011 documented how to create a backdoor using 13 lines of code, a Python code, and then basically how to use PyInstaller to actually make the code itself and to compile it to an executable. And what's interesting is when I wrote this, if you copy and paste this, and this is actually a little bit of an issue from an old template. We're getting this fixed, so this will be fixed like later today, so you don't need to copy that part here. But when you look at this old code here and you copy and paste it into here, and let me fix up the code really quick so you can see it. One second here. So let me fix up this code really fast here. What's funny about this is that up until about 6 months ago or so, and I wrote this in 2011, this code was not being detected by anything out there. There was like a 0 out of 46 detecting this specific one, even when you byte compile it as an executable. So even as an executable, this very easy command and control, simple reverse shell wasn't getting picked up by anything. So I did a tweet about it, and I said, I can't believe none of the AV vendors are picking this up. This is ridiculous. It's been since 2011, and the code for this got I think it was over 750,000 downloads or something to that effect. And so as soon as I made that blog post, the very next day, Windows Defender decided to write a signature for it. And so if I actually try to save this file here, you notice here, no, it didn't actually trigger. Let me make sure my antivirus signature it's on. One second. Let me just make sure it is on. Okay, so this part here is actually what got flagged. So let me actually copy the full thing. I'm gonna laugh. It was this whole thing here. One second. See, if I copy and paste the actual accidental version here that's copy and pasted directly from my website, you can see here that the part that's not even supposed to be there, right here, which is like just a template issue with our CMS that literally shouldn't even be showing on the site or rendering, triggers antivirus. I literally copy and pasted my code directly from the site, but if I remove that and I save it, we still get a detection. So now let's just start building these out here. Start removing some of the basic things. Let's get rid of some of the comment code. Let's get rid of some of this. Let's get rid of this. Now what happens when we save it? Voila, works. So just by removing the comment code, we get around the Windows Defender detection, I guess. So again, not a very good one. But this is kind of the template that we're going to use for building out our first command and control infrastructure. Now this is in Python 2.7, so we're going to update this a little bit for Python 3. But what we're doing here, if you're not familiar with Python, is we're first going to import the Python socket module and the subprocess module. These are the only two modules that we really need to do our command and control infrastructure. So first and foremost, socket is going to allow us to communicate. And down here, we define what our socket is. And notice here we say sock stream, which is going to be TCP/IP protocol. So we're going to be using TCP/IP to communicate. Here we're going to define our host, and you can name these variables whatever you want to. But the host is going to be my attacker's IP address. So we're going to originate an attack on a victim machine, which is going to be my victim machine that targeted via spear phishing or whatever, code execution on a web application, whatever it ends up being. We get our initial code execution on the victim machine, and it's going to reach out to the internet over a specific IP address and port. We can also do host names and things to that effect. And it's going to go over this specific area here to this specific IP address on this specific port, so port 443 or SSL. Now, when you're building out a command and control infrastructure, there's things to take into consideration: what your objectives are, how stealthy you want to be, functionality that you need to be successful. And then from there, building out those capabilities. And so when you're looking at a C2 project, starting off small, but then building out your overall vision. Like for example, a basic C2, I would want upload and download functionality. I would want the ability to execute directly into memory. I would want the ability to potentially load in other interpreters potentially if I want to get execution from a different programming language. I'd want to purely communicate over SSL or TLS. as my main method. So, an HTTP type protocol for communicating. So there are features that you want to consider as you start to make a basic command and control infrastructure, and then things that you want to do to kind of build those out over time. So all of those things are going to be things to use. And I just saw Phaedrus ask if I'm going to use Nano, and yes, I am going to use Nano. Absolutely. So we're going to go through and use Nano this whole time, just to make sure all you VI folks aren't doing anything. But basically, as we go through and do this, this is just an easy way of going through and building out just a reverse shell, and then we'll kind of expand onto there as we go along, okay? So here, again, we define our socket. So we're saying, hey, we want to do TCP/IP. We're going to establish a connection. So this s.connect that you see here is saying this socket, which is going to be a TCP/IP socket, we're going to connect to this specific host on this specific port, okay? That's it. And then once we're connected, we're actually going to send a command that's going to be connection established. So on our attacker's machine, we're going to see connection established. Now, again, there's a couple of other things to consider when building your own C2 infrastructure. You also want to think about multi-threading. If you're going and targeting multiple people, like 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 100, 500 people, you want to have multi-threading in place so you can establish session IDs and things to that effect to allow you to interact with other hosts or other people that you're phishing as you're going through, or other C2s that have established connection. So, again, this is going to be a very basic model, but again, as we get better and better with how we want to build our prototype out, can we build more and more functionality into it to allow us additional ways to use it in our own flexibility. And again, if we build our own C2 infrastructure from scratch, we have a much longer shelf life for detection than if we're using a commodity C2 that publishes their source code in the first place. And it's like with anything. Magic Unicorn's a great example. I wrote a version of Magic Unicorn. I wrote 2 versions of Magic Unicorn. It first came out, I think, in like 2012 or 2013. And that very first version that I wrote, it worked, but it wasn't like 100% reliable, and it was very specific off of 32 and 64-bit operating systems. And so I ended up writing a more cross-compatible version of Magic Unicorn, which was 32 and 64-bit compliant, regardless of it. It was what I called the x86 downgrade attack, or SysWall 64 downgrade attack is what I ended up calling that type of method. And so when I figured that out, I used this new version of Unicorn that I basically built, and I never actually published my original version of Magic Unicorn. Still to this day, my very early version of Magic Unicorn has 0 detections when it comes to PowerShell exploitation. So your code, I mean, that's 2013, so that's 7 years, 6 years, 8 years, 8, 9, 10, 11, so 7 years. Let me do my math right, of non-detection. So you have a much longer time period building and rolling your own than you do using commodity stuff. Now, the great part is that when people release their own public tooling, what's great about that is you have the ability to take what they've used and kind of merge it into your own as far as features and functionality and build that into there, and still maintain that stealth level of command and control for a longer period of time as well. So you can use reference points, ways to do it, but again, looking and building your own is definitely the better option when it comes to command and control. Here we have our basic command and control. Now I'm going to convert this really quick to a Python 3 version that we can go ahead and use. So I'm just going to import socket subprocess, and I need to get my victims or my attacker's IP address really quick. So here's my attacker's IP address right here. So 253.140. Again, this is going to be when we execute our code. What's the victim IP address, the attacker's IP address that this is going to go on? And just while we wait, I'm just going to randomly open up a document or a fake file in Nano for everybody. And so we'll go ahead and hit port 443. So this is the port we're going to connect back on. And this is going to be the same syntax cross-compatible with Python 2 versus Python 3. So we're going to do socket. Is it AF connect, inet, socket, sock stream, and then we're going to connect to our host and port just like before. And then from here, we're going to do like make a connection. So we're going to send, but here's the difference between the Python 2 versus Python 3. We need to send this in a binary format versus a string format, and that's the big difference with Python 3 is the encoding option. So like UTF-8, encoding decodes, things like that make a big difference in Python 3. So a lot of the Python 2 code that you read, you're gonna have to encode them properly and change them a little bit so that it's sending it in a binary version versus strings versus integers. It's very specific off of those. You can't just automatically convert between binaries and strings. So made a connection. We'll give it a carriage return, and that'll be good there. And then we're gonna say while one. So this is while always be this way. Data equals s.receive. So we're gonna receive. And we're going to decode this as a UTF-8, or also known as a string. And so what we're saying here is when we send this, start a loop, and we're going to wait for data to be sent. We're going to wait for the attacker machine, my Linux machine here, to send a command. So we're going to wait for this command to receive it, and then we're going to take that, and we're going to run a subprocess command. Now, subprocess is a module within Python. Notice we imported this before, so if we didn't import this here, we wouldn't be able to type this command here. And what we're saying is proc equals subprocess.popen, and popen is a module within subprocess, a class within subprocess that allows us to execute commands to the underlying operating system. So very much like a reverse shell, right? So we're going to go ahead and take this variable here, data, and we're going to say, hey, data, which might be an IP config, for example. And we want you to run the data command. Whatever was received from these attackers' machines, run that command. We're going to say yes, run it into a shell. And then what we have to do in order to give the data back to the attacker is that we have to pipe out our commands to a pipe. So we're going to take this, we're going to take standard out and standard error, and we're going to pipe this out. Standard in. We're going to pipe this out to subprocess.pipe. And that's going to take all of our output, regardless if we mistype something. It's going to be fully interactive. We're going to pipe it all out to subprocess pipe. So proc equals executing this command that we just received back from the attacker's machine. We've already made our connection, so we're already established connection here. And we're going to go ahead and execute that. Then we're going to create a value for this. And the reason why we're doing this is we're going to combine all of our standard out and standard in, just so we have one real easy way of looking at all of our data in one form, regardless if it was an error or not. We could definitely do this more elegant. If there is standard out.read, then send that data back versus standard out.error. There's a lot of ways that we can go and do it. And hey sub, yeah, this is recorded, so we'll go ahead and make sure that this is published for later too. So when you go through and do this, we're just gonna now send this data back to standard out. And then once we're done here, once we're out of our loop, we can just close this specific instance here. Now we can also do things like if data is equal to quit, then break this loop and automatically close it out, right? So if I type quit for my data received and the variable data equals quit, then break out of this loop, which is this loop is in Python is right here based on the spacing. And so then we would then be at this point in time in Python, and it would say close the socket, which we have an initial connection. So it essentially terminates the connection that we had in the first place. So if we want to put functionality in here, we can do other things too, like hey, if data is equal to info gather, it runs a bunch of series of commands that we want to execute. It'll pull all that data back and then send it back to us that we can use to exfiltrate later. We can make this as versatile as we want to. Thanks, appreciate it. You too. Take care. And so you have these different areas here that you can build your customizations into with whatever you want. So let's go ahead and take a look at this. Now, one thing we're going to do is I prefer PyInstaller over to Py.exe, but it's whatever you prefer. So here's our old one. And again, there's only a couple of minor modifications. Like we had to do this to a binary format. We had to take and convert our data received to a UTF-8. So that was really only the major modifications that we had to make for this specific one to go through and make it Python 3 compatible. But let's go. I'm going to go ahead and exit out this really fast. And what we're going to do is install, or we're not going to install, but it's already here. If you go to pyinstaller.org, pyinstaller.org, you can use it on OS X, you can use it on Linux, you can use it on Windows. What's nice about this specific code that we wrote here, if you notice, this is cross-compatible to any version of operating systems. This will work on Windows, this will work on Linux. and this will work on OS X. There's nothing Windows specific in this. There's nothing Linux specific in this. There's nothing OS X specific in this. So this is all very, very specific. So if you're targeting an OS X system, you can use PyInstaller to create an OS X binary for you to use on your system. Same thing for Linux. You can create an ELF binary that will go and execute a reverse shell directly through an ELF binary. It's the same installation procedures, everything else, as far as that goes. But in this system, I've already gone and downloaded Python 3. I've installed it. The thing that Python 3 doesn't do is add its path variables for you automatically. So we'll manually go through and kind of show that here in just a second. But what we're going to do here is, it is my legit birthday, yeah. Sorry, I'm looking at the Discord, I'm sorry, the Twitch stream as well. So I'm just trying to read questions as I can kind of go along and as I do it. So really quick, Namoon had a question around enterprise environments that you can find and install Python. So we're actually not going to worry about installing Python in the victims environment. What we're going to do is we're actually going to use PyInstaller to create a binary out of Python for us so that we don't have to worry about Python. In an enterprise environment, I would say 99.99999% of the victims that you're targeting is not going to actually have Python in the first place. So we have to have a cross-compatible way of deploying that. And obviously you can use things like PowerShell as your C2 infrastructure, and I'll show you some examples of that with Trevor C2. Trevor C2 already has agents deployed for Python, PowerShell, C#, C that's cross-compatible. A C agent that's cross-compatible from one of our folks over at TrustedSec, Kevin, wrote that one. And so there are a lot of different varying options, and you can obviously leverage scripting languages. PowerShell, I would say, is a less viable option nowadays, just based on the amount of logging that is out there. So can we drop a binary that looks less, that looks legitimate? And I'd recommend too, code signed binaries if you have the ability to go through a code signing process. To get a code signed certificate, you typically just need to register a website and make it look legitimate, and then go through the code signing process. Now, some of them require you to actually have a registered organization, like an LLC or a C Corp. Those are very simple to do to register. We have a number of code signing certificates that we use when dropping our binaries to make it more believable. So there's a lot of different ways of doing code signing on top of a binary that typically gets around EDRs that are looking for code signing certificates and things to that effect. But in this case, PyInstaller is very easy to install. You can use pip. So you can just do pip3 space dash install space PyInstaller or dash I PyInstaller, and this will install PyInstaller. I downloaded the whole thing just to kind of show you what we're doing here. We're going to take it and we're going to go ahead and actually execute it. So let's go ahead and hit command, and we're going to get to our desktop here. We're going to go to PyInstaller, and under PyInstaller we have the PyInstaller. There we go. We have the PyInstaller file here. Now, what I like about PyInstaller, and you can do the same thing in PyDexe, it's whatever your preference is, but it'll wrap everything into its own file, its own standalone executable. You can do the same thing in PyDexe. The thing I like about PyInstaller a little bit more is the file size is substantially smaller. Now, again, when we talk about wrapping a Python script, essentially what it's going to be is a zip file that has script actions that's going to execute the Python interpreter. So it has to wrap the Python interpreter and all the modules that you had to import into that essentially that zip file, and then from there your Python code will actually go and execute. So this is just a way of wrapping your code into a standalone executable that's going to run the Python interpreter. So the file size can be large. It could be anywhere from a meg to 5, 6, 7 megs. And obviously from a more efficiency perspective, writing something in C is going to be a lot better if you want to go for minimalistic agents. And again, I'll show you some examples of that here in just a little bit. In this specific case, though, we're going to take that code that we just wrote in Python 3, and then we're going to integrate it into the PyInstaller piece here. So let's go ahead and take our code that we wrote here. Let's first test it, because that's important. If I could type. Let's just go ahead and run. Actually, I'll just do 1 second. Save that. And then since I don't have so if I go here and I type Python, notice here I don't have my Python path variable. So I can just do a quick path variable. I can just add to my environment variables in the future, which I'd recommend using. But I'm just going to give this the Python 3 directory, and I'm just going to go ahead and run this really quick to make sure I don't have any major syntax errors. And on my other machine, on my Linux machine, I am going to go through. Notice I'm using Nano. And I'm just going to use Netcat to listen on port 443. So if I run this, hypothetically, if I did everything right, should be able to see a connection back from here. Oh, what did I do? What? Oh, maybe? What in the world? 1 second. I'll just add to my environment variables real quick. It shouldn't matter. Path equals it works just fine. I can just go ahead and execute this really quick like this, and I'll add my path variables later. So we get our callback. So notice here we got made a connection. Now we won't be able to run an ipconfig because I didn't add the other path variables like command.exe. So if I wanted to do that, I could, I could fix this here in just a second. But let me just fix this really quick. So if I just run the same command again, and I don't have my listener up, so that's going to fail. 1 second. There we go. All right, notice here now if I run an ipconfig, we get our command and control working. And obviously you can add things like a prompt here, make it look nice. We can type help. We can do whatever we want to make this more user intuitive for us as an attacker, right? So we can add a prompt to this or whatever we want to do. So we can say, right here, we have send. We can do, well, once we receive data, 1 second, you can just put it like somewhere like here. Like that. And then if we do this again, 1 second. Make that a byte. And do that one more time. There, now we have our command prompts. So every time we issue a command, we have a nice little new command prompt. Again, we can add whatever functionality that we want to in this because we're going to be programming it the way they want to. But again, this is just running a Python script on a system. Let's actually get into compiling this as an executable, okay? So let's go ahead and exit out of this. And put the quit part in here. So let's go ahead and save this. This is going to be testing. And what we're going to do, I'm going to go to PyInstaller, and we are going to run pyinstaller.py, and we're going to say --1 file. And this is going to create a file for us that wraps it all into one. So it's going to be all in one file that's going to compile it all for us. We're going to call it testing. And again, you can name the file whatever. It's testing.txt is just an example. It'll execute it regardless if it's a .py extension or anything else. It doesn't make a difference. We'll go ahead and run that. And it's going to go ahead and create our files for us if everything goes right. Takes a second. So we go to testing. And we go to dist. So it's going to create a folder of the name of that file, regardless of irrespective of the extension. So if I named it blah, it would put it in directory blah. And then you have your build, which is more for like diagnostics and everything else that you can see for that. Has pretty much everything it's going to have inside of the file itself. It has the base libraries, everything that you need to do your testing in, so you can modify and kind of play along with it. But this is going to have all of our files inside of it. But in the distribution portion, the dist piece, notice here this is about 5.5 megs. Again, big file. Again, we can write this in C or anything else you want to if you want to do less. I also find that having a larger binary also skips a lot of analysis for both EDR and AV products. So the larger the binary, the least amount of time it spends on it to actually go through. So here we have testing.exe, and if we go ahead and go to the actual directory path here of testing.exe, which contains all of our code, let's go to testing. We'll go ahead and scan this. 0 threats found, so not a problem here from a detection standpoint. Again, very minor modifications to what we initially saw up there. Again, we can continuously build on this as much as we want to. Now we have the ability to have a C2 that runs as an exe. And again, we can use this on Linux, we can use it on OS X, whatever we want to. So let's go ahead and do netcat. Let's listen again. I'm gonna go ahead and execute testing.exe. And here we get our shell. And it works perfectly fine, right? So now we have a full interactive shell to do what we want to. Now again, very basic functionality right now. This is just a command shell. We don't have the ability to upload or download or anything like that. So we want to start building those protocols in as we go along and start adding new features and functionalities. This is our very first iteration of a command and control. We want to start adding the functionality as we go along. So, really easy way for us to build our own binary that has a quick, how many lines of code was that? 14, 15 lines of code total, maybe less than that. We can shrink it down even more. Like, look at, when we're talking about efficiencies, you can take out host and port. This is just to break it out to make it look nice. We can put host and port into here. We can remove all this stuff. You can get it down to probably about 5 or 6 lines of code that we can use to get your command and control to make it as easy as possible. Krent, yes, I am. I'm recording this and I'll be posting this later. And I'll also share the slides and the code. In the slides, I actually put reference points. So here's the code example for this. And I also put links to where you can go and download all this as well. So just FYI, you can do all of that. Yes, netcat is just one line, but it's not your own code that you can manipulate and modify and do whatever you want to. And it gets picked up by antivirus. So that's hence why we're here today. And so, from here, I would, what I would do looking at building on this is I would start to build more of an HTTP protocol for this. You can go over HTTPS. I'd also want to start using TLS and things to that effect. Now, what I want to show you now is a progressional piece that I built, a command and control infrastructure that started off as a very small command and control and has definitely expanded since then. And so if you're not familiar with Trevor C2, it is a public, infrastructure, so use it as directed. Or as you feel comfortable with, but Trevor was originally a Gherkon talk, and with Gherkon, what I did is it was like 3 nights before I wanted to show a command and control infrastructure that did something unique or different, and what Trevor C2 does, and it's morphed since then. I want to explain where it was very first state to where it is now and the progression of what a C2 looks like. And I'm going to show you how you can use these modules to build your own as well and build your own ones that could directly integrate into this. And so on the whole thing on AMSI, by the way, AMSI is a complete joke in every way, shape, or form. To get around AMSI is like the most trivial thing. If you take a look at the blog or the Discord thing that I did a month and a half ago, on how to get around AMSI. I have a whole article or a whole Discord recorded session on getting around AMSI. AMSI is not a concern for us if you know what you're doing in any way, shape, or form. So just that FYI, AMSI is like literally the lowest bar possible when it comes to detections and being able to protect against it. It's static signature antivirus still to this day. It's crazy. Going and I'm just reading off of the Twitch stream, so don't worry about AMSI. In this specific case, when I first wrote Trevor C2, it was a simple HTTP reverse shell that only allowed for one specific session and allows you to go back and forth to go and do. Hang a second. So Alex, quick question from Alex really quick was, the larger the EXE, the more time it takes an EDR to look. So depending on the type of technology or the EDR or AV that you're going against, what typically happens is they'll take that executable and they'll disassemble that executable on the system itself looking for indicators. That could be AV or it could be EDR. Now EDRs are more patternistic behavior on what's actually that executable is actually doing. And so a lot of times they won't necessarily look at the actual file itself and disassemble. That's more for traditional antivirus. But the larger the files are, in order to comb through that code space takes time, and it's an efficiency issue. It's very similar to, if you may not know this, but when you go to scan, like when antivirus goes to scan on a process, even Windows Defender will not scan certain processes like Explorer.exe on process creation or while it's actually up and running through memory, because it's an efficiency thing. EDR products are the same way. How do we make a piece of tool that is less cumbersome than antivirus that allows you to have still the same type of visibility into a system? So as file sizes increase, the less visibility products have in them because of efficiency trade-offs. So if you have a larger PE or executable file, it's not going to comb through every single byte of that application. It's going to rely more on its secondary functionality, which is going to be more on the behavior side. So when you're building a larger size binary, you have a better chance of not getting detected based off of that binary file size than if it was smaller. But at the same time, you still have to worry about these secondary stages around the parent-child process relationships, or command and control if it's automatically beaconing out. That's why jitter commands and actually having commands do random intervals and sending it out time afterwards. Like a lot of times when I do payload detonation, I'll only have it send it after like 20 minutes of the initial execution. So when it gets executed, it only beacons out after that, after about a 20-minute interval. And that's all loose, whatever you want to do for that side. So it's all about trying to figure out how those products work, and then ways that you can kind of circumvent them as an adversary. But with Trevor C2, it was just a basic reverse HTTP shell. Now here's the difference of what happened with Trevor C2 to where it is today now to before. And so before, what it would do is if you run Trevor C2 server, and if you go into Trevor C2, and this is on our GitLab page in TrustedSec, you can go and have it clone whatever website you want to. So what it would do is clone any website that you want. So Google, Facebook, whatever you want to do, it doesn't make a difference. It'll clone that website, and then what happens is that when the payload goes and detonates, it'll go and detonate on a specific system, and it'll call back, and it has essentially a registration process that it has to go through. And what it does is it looks through the source HTML code of the attacker's system, of the Google web page that I cloned, and it sprays the command and control instructions through the code dynamically each time. So let's just say, for example, I want to do an ipconfig. What would happen is it would take an ipconfig, and then it would take an advanced encryption standard, or AES. It would encrypt that command and then spread it randomly through the HTML source itself. And then what would happen is the client would then look at that site, reassemble it, already has the encryption key baked into the client itself, and it would reassemble that command, then execute that ipconfig. Then it would exfiltrate that data through GET requests that make it look like it's loading the website itself. So it's a heavily obfuscated way of identifying command and control within an infrastructure. And then if the, let's just say the incident responders got wind of it, if you directly went to the website itself, it would do one of two things. One, it would just load the cloned website, so it would just load a copy of google.com. Or the second thing it would do is it could redirect you to the legitimate Google site in the first place, because you're not a registered agent. So if you didn't have that registered agent way of looking at things, it would not allow you to actually inspect the code of the site itself and just automatically redirect you to the legitimate site itself. So it's a way of kind of messing with defenders. Now, since then, this has taken on a whole new life. Originally it was in Python, but I made a framework for it so that you can create other types of agents. So if you go into the agents directory, notice here we have a Python version of Trevor C2, we have a client, a PowerShell version of Trevor C2, we have a Java version of Trevor C2, and we have a C variant of Trevor C2. And this one was done by Kevin in here, but this is a version of it that was written that allows you to basically go in and be cross-compatible with a lot of different programming languages. And sorry, that CS is C Sharp, my bad. That's the C Sharp version. As I started looking through the code, I'm like, that's not C. The C version is actually its own file here. So you can see here is the makefile for the source code here. So you have a lot of different versions of Trevor C2 that you have now available. And since then, Trevor C2 can support TLS. It supports the ability for upload and downloads. It supports the functionality for multi-threading. So if you have 7,000 agents, you can interact with the different agents themselves. It allows you to basically be an extensible framework for command and control that you can go and do. So let's go ahead and take a look at this really quick. Now, funny story really fast. I released Trevor C2 a number of years ago back at GERCON. And let me get to the PS1. And I had not had to have changed the PowerShell code for several years. And just about 6 months ago, I was giving a talk, and somebody from Microsoft must have been in my talk and actually wrote a signature for it. And all I had to change, and this is an example of how terrible AMSI is. So AMSI was snagging this specific flag, or these specific these two lines of code right here, and it was looking for a variable name defined as encrypted stream. So it was looking for this. As soon as I put an S there, It completely got around AMSI and I'm going to rephrase that. AMSI is just a provider. So there's AMSI scan string and AMSI scan buffer. AMSI scan string will use the AMSI provider to scan. So I'm not saying I got around AMSI because AMSI is just a provider of PowerShell to subscribe to. I got around Windows Defender, which has a signature for that they subscribe to AMSI to detect that. So hopefully that explains that specific piece there. But AMSI is just signature-based detection. It's nothing more than that. And so all I had to do was change this to encrypted streams. And since then, we still haven't had any detections written for Trevor C2, and it still works perfectly fine out of the box without any detections on that front. So we're going to go ahead and use Trevor C2, and we're going to go ahead and give it our victim IP address. Our attacker IP address. So it's 253.140. Let's go and copy that real quick. Now, what I'd recommend if you're going to go ahead and use this, obviously submit it to HTTPS and get your own SSL certs and things to that effect. And I'd also remove all of this default comment code here, right? Remove all the comment code. I would change these variables. So site path, these are all configurable things that are out of the box. So change these so that they're not the defaults in what you're actually going after, because these are the things that are going to get flagged. Also, change the encryption key, right? Encryption keys are this, and this is static. Change it to your own encryption key, so you go through and do this. You can also run it through a number of obfuscators, like PowerShell obfuscate. There's PyObfuscate for Python. There's a lot of ways of running this code through obfuscation that make it much harder to actually go and detect, okay? Now, if you do change some of these variables, like the GUID or the images, you have to conversely go ahead and change it in the server side as well. So here's the things you just changed in the different areas. So you have GUID, you have images, you have your root path, and again, these are all things that line up directly with this. So if I go ahead and change these, I'm gonna have a much better way of handling non-detections here as we go through. So we're going to go ahead and run this, and then we're just going to clone Google as an example. Now this is Python 3 support, so it's all Python 3 compatible. It's going to go ahead and clone Google. So notice here, and we got our a hacker tool is not a hacker tool without ASCII art, by the way. Just don't at me, but got to have ASCII art. That's the most important piece. And so here we see cloning website google.com, site cloned successfully, started Trevor C2 server, and then now we're just waiting, right? So we type help. And here we have a couple different options available. We could, type in ifconfig. This is just a quick one to get your IP address if you need it really fast. You can also, interact with ones, and we list. So if we go ahead and hit list, notice here we have no available shell. So we haven't executed this yet. We have no availability to go and do this itself. So we have to wait for our shell to come back. And obviously here, these are different areas we'd want to take a look at. Now here really quick is what we call jittering. And jittering is a way, there's a lot of ways to do analysis on command and control. Like for example, if it's going to a specified IP address and then it's beaconing back every 5 seconds, a threat hunter can say, let me look at anything in our environment that is communicating at a certain interval on a regular basis. So like every 5 seconds or 10 seconds or 50 seconds or whatever it ends up being, can we look at that in our environment? So jitter is employed to create random time intervals of when it actually calls back. So this will call back every time between 2 and 8 seconds. So everything in between there. We can obviously increase this to 50 seconds and 10 hours if we wanted to, whatever we want to do. We're just going to keep it 2 and 8 just as a base for that. But just ways that you can kind of look at that and say, okay, well, are there ways for us to handle non-detections? And so again, we can just delete all this stuff. We can delete all this stuff in here. We can rename these variables. However you want to do it. You can go as deep as you want to into all of this and obfuscate all this stuff itself. Daniel Bohannon has a great tool, the obfuscation tool that goes and actually obfuscates all the code for you automatically. So there's some great stuff out there for doing it very easily. But let's go ahead and run this. We have our server running. We'll go ahead and hit play. And notice here we get a connection, and it assigns it a unique SID for each of the agents. So if I had 10 different command and control infrastructures, I could use 10 different ones or 100 different ones or whatever else. Those would be a way to do it. Now all these communications that we're doing are all going to be over HTTP GET requests. So there's no post data. So there's going to be no post whatsoever. And all that data that's being obfuscated is chunked up into different sizes through AES encryption and then it's going to be basically funneled off by what we perceive as viewing images on a website. So going to a website, and it's going to simulate a user actually loading that website and all of its various components. So it makes it look like it's actually doing a GET request to load a website, to be more tricky when it comes to detection in that specific area. So it's a really crafty way of kind of getting around traditionalized detection pieces on here. And so we're going to have a different SID every single time. It's going to connect to this specific IP address. And then we're going to go ahead and list. And notice here now we have our established command and control infrastructure. Now we have a jitter between 2 and 8. So it's not going to be immediate feedback when we go and actually issue this. We're going to issue an IP config. And then it's going to be just a way to delay that a bit so that we try to evade a little bit of detection. So we're going to go ahead and interact with this, interact 1. And we're going to go ahead and IP config. It's going to take a second, between 2 to 8 seconds. We should see this come back. And notice here, we get our IP config back, right? So now we have the ability to go through and execute our command and control directly through it. And we have other options too to go and execute this as well. Actually, I can't hit help from the specific one, but I should definitely add that. So those are things that you can kind of do to mess with it, but it's a very extensible framework to go and play with if you're interested. It's got various different agents you can go and play with. It's got a PowerShell version, as I mentioned before, the Python version, Java version, the C# and the C versions to go and play with. Again, things that you can go through and kind of mess with. One really quick question. So what's the point of patching AMSI if you can just change the variable names? It's a very good point. Patching AMSI is a way to just show the ineffectiveness, because what with AMSI is running under the context of your user account. So AMSI is running under the context of your user. You can patch that memory space because it's not an elevated permission process. So AMSI really is trivial because you can completely disable it in your process space or disable it completely. And then from there, execute whatever code you want to without any detection based on the AMSI providers. So that's kind of the benefit of patching AMSI so that it can't get through. But the same thing is that, yes, you can get away with variable substitutions very easily and chunking things up to get around the AMSI provider's detection for the signatures that they wrote for that specific case. So there's 2 ways of really tackling AMSI and PowerShell to get around that. But really, it's all those different areas it's all that attack what you want to get around, how you want to do it. What's also great is when you're patching AMSI, it's not just Windows Defender you're trying to get around. If there's EDR products that are AMSI providers, ways of getting around that, they might do more analytics against the code. There are ways of things that you can do to go and play with it. Yeah, you can absolutely just shut it off. You can patch the memory space itself and completely disable it. There's a lot of different AMSI techniques out there today. But wrapping things up, I just wanted to show you some simple ways that you can build command and control infrastructures, the progress of those, making an executable out of that, how easy it is to really go and accomplish, get around traditional detection methods. Here I have some resources for you, and I'll share this. And this video is recorded, so we'll make sure we publish all this. And I know I talk really fast. So you can go to TrustedSec.com/blog/creating a 13-line backdoor where you're free of AV. The PyInstaller installation methods are right there. It's super simple. You download, you run it, you install Python, you're good to go. That's your testing environment. It should take you no more than 5 minutes to set up. And then Trevor C2 as an example there of a command and control infrastructure that I built for fun that has gotten a lot of community support as well. The additional modules, some amazing people, Ginger Hacks and a number of other folks, Kevin, have built other modules for those as well. So great reference points there for everybody. But that was really it. Does anybody else have anything? Any questions? I have a call actually at 2, so I have to get off here fairly quickly. But does anybody have any questions I can answer last but not least?
Dave Kennedy, the one man that can give a 2-hour talk in 1 hour.
Yes, I can give a 2-hour talk in 1 hour.
I feel educated. Thank you.
Yeah.
All I'm gonna say is happy birthday. Yep.
Thanks, man. Appreciate it. Thanks so much. I really appreciate it. Oh God, Olaf's there too. What will my bourbon be of choice today? I will probably go for a Eagle Rare today. Is going to be my my birthday celebration bourbon today. So it's kind of my go-to drinking bourbon nowadays. Maybe a Weller 12. We'll see. All right. Well, hey, I appreciate everybody hopping on. Thanks so much for spending some time with me and my birthday.